Today we will discuss the power angle curve diagram. On this graph, the horizontal axis is the load or torque angle in electrical degrees, and the vertical axis is the real power P transferred between the synchronous generator and the infinite bus. Here we have drawn on the x-axis, that is the 0 degree, 90 degree, 180 degree, 270 and the 360 degree, and on the x-axis we have drawn the delta, that is the load angle or the torque angle and on the x-axis we have done the power. Now the power angle, the curve we are plotting is the classic relation, that is we know that is the P is equal to EV of EV by X of sine delta. We can also write P of delta is equal to EV by X of sine delta. So the shape is the sine, so the shape is here is the sine wave. The dashed line marks the maximum power, that is P of maximum. P maximum is equal to, already we have derived in the last class that P max, we know that already we have written P is equal to EV by X of sine delta. So we can see here in the diagram delta is at 90 degree, so sine delta means sine 90 is equal to, sine 90 will be equal to 1, so EV by X will be sine 90 degree, so it will be equal to P is equal to EV by X. Now start the curve at delta is equal to 0 degree. From here we will start that at delta is equal to 0, sine 0 will be equal to, we know that the sine of 0 will be equal to 0, so the real power will be 0 at the angle of 0 degree. The generator EMF is aligned with the bus voltage, no net power is transferred, so at the angle of 0 degree. So now it starts the now the rising of the 0 to 90 degree to this point. So at the angle, at the delta, at delta increases from the 0 to 90 degree, the sine terms increases, so the real power rises. This is the called the generator action. Power flows from the generator to the infinite bus. So maximum power is the P maximum will be at the here. So P max formula will be the P is equal to EV by X. EV by X. So again we can see here that beyond 90 degree, even though the angle increases, the sine decreases, so the available power falls, but at the angle of 100 degree, 180 degree, at this angle delta is equal to 180 degree, the real power returns to the 0. So for this graph, at the 0 we have seen, at the 90 degree we have seen, again it falls from here to here at the 180 degree, so at the same power returns to the 0. Now we see in the negative half that it decreases from the 180 degree, it comes to the 270 degree, and again it comes to the 360 degree. The most negative value occurs at delta is equal to 270 degree, delta is equal to 270 degree. Then it returns to at the 360 degree. So what the slope means, that is the that is the stability intuition. The slope of this curve, that is the dp by x. We can write here that dp by d delta is equal to ev by x cos of delta, each called the synchronous power, with delta less than 90 degree the slope is positive. A small disturbance produces a restoring torque, so the operation is stable. Near 90 degree the slope approaches zero. Synchronizing torque is weak and the system is vulnerable to loss of synchronism. So we can say in summary that the power angle curve is sine wave of the power versus load angle. The upper half is the generator action and the lower half is the motor action. Lower half is the motor action. And the maximum steady state power is P max at the delta is equal to 90 degree. This diagram is central to understanding how much power a synchronous generator can transfer and how close it is to its stability limit. So I have written some of the points here that whatever I have described here, that in the theoretical part, that we can see here that the graphical representation of the power P and the load angle delta is called the power angle diagram, and it is also called the power angle curve. Such diagram is widely used in the power system stability studies. Maximum power is transferred when delta is equal to 90 degree. As S is increased beyond 90 degree, power decreases and becomes 0 degree. At delta is equal to 180 degree, beyond delta is equal to 180 degree, the power becomes negative, that is the power direction is reversed and the power is supplied from the infinite bus to the generators. Now thank you for watching. Don't forget to like, share and subscribe for more power system tutorials. Thank you.